Hi, everyone. Thank you so much for joining this talk and for joining the Data Science Conference. I'm really excited to be here today and for this talk over the course of the next 20 minutes. All right. So today what I'm going to talk about is fairness. My name is Tulsee, and I lead product for the ML Fairness and Responsible AI efforts at Google. So that means I work with a number of amazing research scientists, engineers, researchers who don't focus on computer science, but rather focus on social science and a number of the other aspects that are so critical to fairness in terms of societal context and historical context. But I also work with Google's product teams to think about how fairness translates in practice to product and what it means when we want to actually take ML fairness concepts and put that into practice. And so today what I'm going to talk about is some of the nuance that happens when you talk about fairness in the context of metrics. So first, just of course to take a step back and set the stage, AI is really being used all around the world. And as we start using AI in more and more ways around the world, it becomes more and more critical that we be thinking about inclusion and fairness. AI is being used in healthcare. It is being used in climate change. It is being used to think about traffic in our streets. But at least at Google, AI is really just being used in all of our core product experiences, whether that is how we rank and recommend content on search or YouTube, whether that's about the way that we interpret language in the assistant, the way we think about advertising, the way we think about access in Drive, right? So ranging from sort of simple use cases to more complex use cases, AI is really permeating through our product experience. And so for us, it's really important that we think about the principles by which we're defining those experiences, thinking about the things that we really want to make sure the AI that we're building represents and things that we want to make sure it does not, right? In particular, today, I'm going to be focusing on that second principle. How do we think about avoiding, creating, or reinforcing unfair bias? And, the way that we think about a lot of our work throughout Google is by focusing on metrics. So naturally, when we think about that second principle, avoid creating or reinforcing bias, the thing that we jump to, often first and foremost is like, okay, but how do we measure that, right? Like, what does it mean to have in our systems? How can we quantitatively represent that? And what does that actually look like? And while many experiences manifest in very different ways, I think the question is, how can we represent that in a way that we can measure and track and improve over time? But the problem is, of course, with fairness, that metrics can get really complicated really fast. In fact, at the FatStar Now Fact Conference in 2018, Arvind Narayanan pointed out that there are at minimum 21 different definitions of fairness. And that is just in the context of a classification system where you're labeling content for one use case or another. As you start expanding that into recommender systems, content generation systems, the way that you define and can think about fairness continues to expand. And so that means that we actually need to be really careful about how we're defining this space and what we're talking about. So of course, then the question becomes, how do you pick the right metric? What does that actually look like? And I think the key thing that is really fundamental to remember in this process is that humans are at the center of the technology, right? So we are building the technology, we're also the ones using that technology. And so fairness concerns are first and foremost societal constructs that are then embedded into our product design decisions, right? So where you get your data and who labels that data may affect what that data looks like, then how your model is trained. Where you live and your experiences might affect how you think a product should be used or the objective that you think a model should have. The goals that we have from a product perspective in terms of how we define success may trickle down and affect our product design decisions in numerous ways, some that may be inclusive and others that may not be. And so I think it's definitely really critical to take a step back and say, what do we really mean when we're talking about fairness? What is the experience we want to create? So let's look at an example. And this is an example that I have to give credit to our Jigsaw toxicity team for working on and sort of raising awareness of. But this is an example that our toxicity team, this is the Jigsaw Perpsective API that has been working on creating classifiers to detect hate and harassment in online conversations. When they first launched this API in 2017, they hadn't necessarily thought as much about evaluating for fairness in the evaluations. And when a user tried the API, they found this horrific example. When they used the word "I am straight," they saw a score of 0.04. And when they typed in the words "I am gay," they saw a score of 0.86. Now, what does this toxicity API mean? Well, if a a sentence gets a score close to 1, that means that it was highly likely to be toxic. That means our classifier was saying this is probably something that in an online conversation is considered to be toxic, whereas something close to 0 was something that was considered innocuous. And of course, this kind of bias where you see the sentence "I am gay" tagged with this score is not an experience we wanted to create. It's not something we wanted the API to persist. And so the toxicity team said, hey, wait a second, this is something we want to improve and something we want to learn from and make sure it doesn't happen again. So they started with, okay, what's the first set of metrics we want to evaluate? And the first set of things we would think about are, well, equality of opportunity. We want to make sure that examples from 2 groups or communities have equal likelihood of being classified correctly or incorrectly. So if you have a sentence that is not toxic, it should be classified as non-toxic an equal percentage of the time for communities from the LGBTQ community versus communities from the non-LGBTQ community. And so the team developed, a set of metrics to measure equality of opportunity. And what you can see in this chart is that the darker purple represents a higher set of error rates, higher false positives in terms of classifying content as toxic when it has certain terms. And the lighter the color gets, the closer we are to lower false positive rates. Things seem to be working well for particular identity terms. And this was great because over time, the team was able to essentially improve these metrics to make sure that by the time we reached the 6th version of the toxicity classifier, we were at a place where everything had gotten a lot better, where the error rates overall for all of these terms had come down. This is a great example of a way that a metric can motivate progress, right? Having the first set of metrics, being able to really track and measure not just the single example that the user found, but at scale. What was happening for some of these identity terms across hundreds and thousands of comments allowed us to then say, well, what are the ways that we can improve this at scale? And then be able to track that progress in a way that the team can consistently look at. And now, even when numbers are looking better, continuously track to make sure we're not regressing or that something isn't changing. But what is the metric not telling you? Well, here is another chart of the toxicity V6 classifier. And here the numbers don't look as good, right? Just as a quick recap, here you see things as, a lot more close to the white end of the spectrum. Here you see things a lot more purple. And the question is, what changed, right? This is the same model, it's the same version, it's the same terms. Why does this look different? And the biggest piece I think that we found as we were looking at this is the data and what we were actually evaluating on. This first version here was evaluated on a set of synthetic comments. So what the team did was they created a bunch of comments that looked like I am straight, I am gay, I am Muslim, I am male, I am female, trying to really understand, a broad set of identity terms, but creating sentences that looked very similar, right? And just changing the identity terms, replacing one set of identity terms with another. That definitely makes sense and is an approach for being able to test how these things look compared to one another and how these sentences might compare if you had the general structure the same, but you were changing key valuable identity terms. The second data set was created by organically sampling terms from comments from the internet that had particular identity terms in them. So here, maybe users are less likely to say the sentence "I am straight" online. And so the types of comments that contain that term might look very different. Maybe the comments that contain the current term Christian online may look very different as far as the sample is concerned over comments with the term Muslim. And so as a result of that, the team found that when they actually looked at comments that weren't synthetically generated, but online on the web, the story didn't look the same. And the data that you have underlying this evaluation, even if the core metric is the same, can change your perspective on whether something is fair or something is not. And both are valid evaluations. The first tells you when you create a sentence, how likely are you to perform differently on that sentence if a different identity term is in that sentence. The second tells you of the sentences that are most often used on the internet in your random sample, how are we performing on those? They capture 2 parts of the experience, 2 ways that users can experience harm or experience fairness concerns. But now that the team evaluated this, they were able to actually track and measure this metric and are now improving that in the future versions of the toxicity classifier. The other thing that's worth noting is what is the fairness problem that you are solving? This picture is from an article that was released that talked about the Perpsective API toxicity score over sentences that were in different vernaculars or different types of speech, focusing on African-American phrases in English used in many places across the country, as well as traditional sort of non-African American vernacular. And as a result of classifying these, they found higher error rates in certain contexts. And this, of course, is not captured in this measurement, which looks at identity terms in the sentence, not the way that the person is writing the sentence, the types of language that they might be using, or the different framings or phrasings. We realize that it's not just important for us to evaluate identity terms in the sentences, but also to evaluate and understand how different types of sentences, different types of sentence structure, different types of speech might affect the outcome in the performance. So what are some of the key lessons that we've learned in this process? Well, one is that metrics are great, but they're limited to the data set that you evaluate them on. So it's not just important to be clear about what it is that we're trying to measure, in this case, equality of opportunity, but also how we're measuring it and what the data that we're measuring says about the experience that we're tracking. Also, that there is no one such thing as a single fairness evaluation. Different fairness concerns require different metrics and different data sets, and likely an approach that you take when evaluating your own product is going to have multiple metrics across multiple different stages. There's no substitute for diverse user research and testing. And I really want to underscore this lesson because for us, one of the key ways that we often find these fairness concerns is through a user raising them, either in an experience that they've had with our product or in dog fooding where we test our products. And for us, we really want to make sure that we understand this before it affects a user in a harmful way. We want to understand it when we're developing the product so that we develop a product that is truly inclusive from the beginning. And doing that can only happen if you have diverse voices in that room. If you're getting feedback from diverse users, if you're understanding what are experiences that individuals have had online or may have online that are different, and how might this kind of product facilitate or not facilitate those experiences. The last piece I want to call out is just being clear and transparent about the metrics, data sets, and assumptions that we're making. Every metric is a choice. It's a choice to measure in a particular way. It's a choice to optimize for a particular outcome. It's a choice to think about a particular user experience. And the assumptions that we make throughout that process are critical and can greatly change how we think about fairness. Just take a look back at that original example I showed you of measuring on synthetic data versus measuring on online data. Both of those experiences make fundamental assumptions about what it is we care about and what it is we want to measure. And so I think it's really important that we actually be really crisp about those articulations and those assumptions, so that way, whether we think it's the right approach or whether later we decide there's a different approach we want to take, we can understand and talk about the pros and cons of those cases. So on that last point, I just want to talk for a few minutes about intentionality and transparency. You know, the reality is, again, as we talked about earlier, humans are at the center of the technology, and we are the ones who design and develop and think about the decisions that we make. We make the decisions about the metrics we're going to use, about the data sets we collect, and how that influences our system over time. And so it's really hard to figure out how to untangle human bias with the technology that we create. And so the fairness that we're building into our product development is heavily contextual. And so as a result of that, I think it's first and foremost important to be intentional and transparent about each and every one of those choices we make. So one call to action I'll put to all of you who are listening today is to document your choices. Here you have an example of Google's first model card. Model cards are something that came through many of Google's research efforts as a way to think about transparency in model development and design. Built off of data sheets and inspired off of data sheets in hardware, model cards really focuses on documenting the use cases for a model, the limitations of a model, the trade-offs for a model, really providing a crisp articulation of what the model is and is not meant to be used for, and what are the cases where the model might fail. The model cards also contain really detailed information about the performance of the model. So what is the recall of the model for a face detection system across different age groups, for example? And can we actually provide those fairness metrics so that any user who is picking up this model and going to be using it for a different use case is aware of the cases where the model might work well and aware of the possible failure modes? It also puts an accountability on us as model developers to make sure that we're building a model that we are comfortable talking about, comfortable documenting. The other place where we think it's really critical to think about documenting of choices is data cards, right? Thinking about how we build up data sets that are thoughtful, that reflect the assumptions that we're making. Data cards allow us to capture things like, is this data synthetically generated? Did it come from a random sample online? Who published the data? Who labeled the data and how did it get rated? What are the use cases? Why was this designed? And what might this not be good for? It allows us to capture things, for example, like the languages that a dataset represents or the geographical reasons. For example, this dataset that I'm showing you here in this data card is the Open Images Extended dataset. This was a dataset created to help make the Open Images dataset externally more diverse. Make sure that it covers more regions across the globe. So if you were just looking at that dataset, you may think, hey, if I have a global use case, this is the dataset I should use because it captures a global representation, it has 500,000 images, and it's meant to capture underrepresented populations. But when you look at the geographic distribution of this dataset, 83% of the images come from India. So while the dataset is a great way to increase representation and especially make sure that the South Asian context is better captured, it may not well capture other regions that are also underrepresented across the globe. And here you see, for example, 2% of the data is from Vietnam, 2% is from Brazil, but the dataset in and of itself has a particular distributional skew. So there is a global intent here, and it is more globally representative, but what does that actually mean? Data cards allow us to get that level of granularity deeper and provide some of the context that can affect the metrics, the evaluations, and the improvements that we make downstream for fairness contexts. The good news, too, is that we actually have a tool that can help you with these things. Earlier this year, Google released the Model Card Toolkit, and you can find this if you go to Google's TensorFlow Responsible AI Practices, and I'll have a link here in just a second. But we know that creating these documentation can be hard. We know that going back and tracking all the artifacts of your model design and development can be incredibly time-consuming and incredibly challenging. It can also be challenging to figure out what you should put in a model card. What are the right schema elements? What are the right pieces you should talk about? So here with the Model Card Toolkit, we actually using the model, using MLMD, which is a part of the TensorFlow Toolkit, you can actually track and store the lineage and artifacts of your model, populate a model card JSON instance, customize that template with any sort of schema elements you want to have, and output a model card in a beautiful HTML presentation that then allows you to use this going forward. We're continuing to work on improving the schema, the template, the work with MLMD, as well as the final model card UI that you can look at to make sure that model cards can be flexible and can support diverse use cases. But would definitely recommend that you try this for your own product examples and experiences. Some other quick tools and resources in the last few minutes that I have. As I mentioned, we're working on building a responsible AI toolkit. And so if you go to tensorflow.com/resources/responsible-AI, you'll find the model card toolkit I just talked about, but you'll also find projects ranging from helping you define the problem when thinking about responsible AI, to constructing and preparing data, to building and training your model, to evaluating your models using many of the metrics that I just talked about, to actually deploying and monitoring your model over time. Each of these has had multiple projects internally for us to establish and refine our techniques, and we're continuing to add more of these to establish these techniques going forward. Some of the examples of the projects that are part of this responsible AI toolkit, in addition to model cards, are thinking about data set slicing and evaluation. So how do we help you understand the representation of the data set across, say, geographic regions, across skin tones if your data set is visual? How do we evaluate your model performance for things like equality of opportunity, which I talked about earlier? And when you find a problem, how can you deep dive into the examples to do analysis? Fairness indicators is one of these tools that allows you to compute some of these common classification metrics for any individual group and visualize it compared to a baseline slice. The what if tool then allows you to dive deeper into one of those slices to ask finer grained questions about, why is the model making a mistake here? And can I help understand what features might be contributing to that issue? I know we're about at time, so I want to stop here, but I want to call out that in addition to fairness indicators and the what if tool, we're continuing to work to add tools to our library, and we want to continue to work with and learn from all of you. So please do check out tensorflow.com/resources/responsible-AI. Check out these tools, try them out, but please give us feedback on what is working for your use case and what is not. What are cases where there are definitions or metrics for fairness that are not captured here? What are nuances that you are finding in your experience so that we can continue to build up the toolkit one case study at a time, one experience at a time, and be really thoughtful and careful about how we're building this up? Thank you so much for joining.